Yes. Okay, here we have exploration 2. This is uh, identifying weather associated with pressure systems. So another important aspect is pressure systems, and a lot of time you see charts like this that talk about pressure systems. These look like a lot like topographic maps. If you've ever done like hiking or anything like that, where it talks about elevation, but these maps show pressure differences. And one of the things that you want to check out is how these actually. I'm gonna go back over here so I can draw on it. I didn't think of this. Let me find the right page. Here we go. All right. So with these maps, right, you can see these. You have these lines right here. I'll highlight them in purple. So you have L right here. This is low pressure. Remember that low pressure is going to be warmer, right? The molecules are spread out farther, so it's warm air, low pressure. That's why the H's are blue, because H's is high pressure, and so that is, high pressure. It's going to be blue because that's higher pressure. The molecules are closer together. It's colder. There you go. So you can see these lines. As you draw these lines out, right, the L is the lowest pressure right over here. It's right over here. And then as you go around, right, so let's say we have a pressure of 996, right? Then we move farther out and it's 1,000. Then you move farther out from that and it's 1,004. And then you get farther out and it's 1,008. So as you go in this direction, getting closer to the L, the pressure is decreasing. These numbers are decreasing, right? Just like the H, right? You look at the H. As you cross these lines, getting closer to the H, right? What's happening? The pressure is increasing. This is the highest pressure right here, and then you get farther away from it, and it's getting less. Or as you get closer to the H, the pressures are increasing. So, let me erase those, otherwise you'll all see them in the key. So in my line, I drew this blue arrow right here. And so it says describe, and I wrote it down here, but what's happening is I'm starting up here. So I'm starting and I'm getting closer to this H at first, right? So at first it's going to be a little bit low pressure, like even right here, 10, 20 is about where I'm starting. Then I'm getting closer, right? Now I'm at this line, this is 10, 24. Then I'm at the H, that's the highest pressure. Then I start moving this way. I'm getting farther away from the H. I'm going lower pressure, and then I get to this area. This area, there's really no lines, or these lines are meeting. So you can actually see how this line and this line represent the same pressure. So there's not much pressure change happening in this area right here. But then as I continue going closer towards Florida, right, we got 10, 12, 10, 16, the air pressure starts increasing again. So that's how these diagrams kind of work. So this is talking about if you're identifying the best place to build wind farms. They said they did research to find the average wind speeds. The other thing that you might want to know is the average wind direction, because you'd want to know if the wind direction is constant. If it's really windy in a certain area, but the wind direction is constantly changing, then that wouldn't be a great place to put windmills, because they're only pointed in the right direction some of the time. So you'd want to find a place where it's windy and the wind is pretty much always in the same direction. So, when you have your windmill chilling someplace, the wind is always going past it in a certain direction. So here is a little summary of the pressure systems. And you can see right here, it says, this is a great paragraph. I highlighted it in two colors because this first one says, high pressure systems, the air sinks, it gets warmer, the relative humidity decreases, and if there are clouds, the clouds evaporate, and they usually have clear skies and calm or gentle winds. That's a great summary for a high pressure system. And then low pressure system is essentially the opposite. It rises, right? So this diagram shows it perfectly too. So like in the high, right, it says that the air is going down, it's clear, the air is moving counterclockwise, the air is moving away from the high pressure system. Okay. In a low pressure system, the wind is coming towards the low pressure system. The warm air is rising, and because it's rising, as all air rises, it's going to get cooler because it's cooler higher up in the atmosphere. So the air is rising, right? It's condensing down. You want to think that on the surface, it's warm air. Warm air can hold lots of water. It goes up, it gets colder. Well, when air is colder, it can hold less water. So as the air gets colder, right, the same air has the same amount of water in it, but all of a sudden that air can't hold as much water, so the water starts condensing into clouds and can be rain. So here's this. I just said all this stuff, so I'm going to kind of skip by this. What kind of pressure system was probably involved in Utah? I would say a low pressure system, because a low pressure system is going to be drawing in air to it and creating more clouds and stuff like that. So I'd say low pressure system. Interpreting a weather map. So you have to put these word bank questions in this weather map. So here you can see this is a high pressure system, and just like it says up here, right, high pressure is going to be clear, calm. So it's going to be sunny and calm. Also, you don't see all these isobar lines. These lines are called isobars, right? And which means that the wind isn't changing as much. Right over here, right, low pressure systems, all the low pressure systems over here we got rain, low pressure over here we have rain, and in this area right here where these isobars kind of from the high pressure system and the low pressure system, they're all kind of like colliding right in here, right in this area, and that is causing all these more extreme weather conditions like the snowstorms and the wind. And patterns that you would notice, patterns that you should be noticing is, look, there's rainfall around the L's, the low pressure systems, there's rainfall, and around the high pressure systems, right, it's clear and not a lot going on. That's it for Exploration 2.